Here's number 48 on section 5.1. And first of all, we want to look at the problem and see what we've got. Well, it doesn't look too bad because we've got a fraction on the left, a fraction on the right. But they're both really not in terms of the sine and cosine, so we're probably going to have to work at this a little bit. And sometimes what you can do is you can work on both sides and try to get them both to equal the same thing, especially when they're pretty bizarre like this. They're nowhere near the sine cosine. So if I get this to look like the sine cosine, then this is going to be pretty bizarre, so I'd have to do like a lot of work to get this to look like this. So sometimes you can work a little bit down the left side and get it in terms of the sine and cosine. Then you work down the right side, and if they're both, if you get something on the left equals something on the right, then you're in good shape. So that's another approach. So that's what we're going to do, because I could do it, but it'd be pretty challenging. Okay, so first of all, I'm going to make everything on the left. I'll try to get both sides to be in terms of the sine and cosine, and go for there. That's the bottom line. So the cosecant is the same thing as 1 over the sine of t minus 1, and that's the top of the fraction. And the cotangent is equal to the cosine of t all over the sine of t. And we got a nice complex fraction there, and we know how to take care of that. We multiply the top and bottom by the LCD. This is like over 1. So I got sine 1 sine, so the sine of t is my LCD. So put a little parentheses around there. And we'll multiply the top and the bottom by the sine of t. So this 1 over sine times sine is just 1. So that's nice. Minus the sine of t. And on the bottom, these cancel, so I've got the cosine of t. Okay, so let's take a look at the right side and try to get this to be in terms of the sine and cosine. Okay, so this is going to be on the top. I'm going to have the cosine over the sine. That's the cotangent. Cosine of t over the sine of t, that's on the top. And over here, this is going to be the cosecant, which is 1 over the sine, plus 1. And then again, I've got a complex fraction, and my LCD is going to be the sine. This is like over 1, so I'll multiply the top and the bottom by the sine. Okay. Now these cancel, so up on the top now I've got the cosine. And on the bottom I've got, let's see, these will cancel, so I've got 1. And then I've got plus the sine t. Okay, so now I got both sides in terms of the sine and cosine. Alright, so what am I going to do now? So they sort of alike, I mean, except they're kind of flipped upside down. I can't cross multiply because this is, I'm trying to show that this side equals that side. So I got to do something to one side to make it look like the right side. So let's see here. What can I do? Okay, well, I've got a cosine down here. So is there some way I can get a cosine down here, or I can get a sine up here? Actually, 1 minus the sine. So so let's take a look at that. I have a 1 minus the sine of t on the top. So let me just try to get a 1 minus sine of t at the top over here and see what happens. All right. It is an identity, so it should work out. So if I want to make this look like this, this has got 1 minus the sine of t in the top. This doesn't, so I'll just put a 1 minus sine of t in the top and see what happens. 1 minus the sine of t. But what I do to the top, I've got to do the bottom. I hope that's going to work out. I mean, because I know I've got to end up with this on the top anyway. And then I'll put a binomial parentheses around it because I'm multiplying the whole thing. And I'm going to leave this on the top. I don't want to mess with that because, that's almost that's what I need there. So I got the cosine of t, and I've got my 1 minus the sine of t in the top. So I'm beginning to make the right side look more like the left side. And I've got this. Now that's like a plus b times a minus b, and if I multiply that out, okay, I'm going to get 1 minus the sine squared, and I know that's nice. So I'll multiply that out. 1 minus the sine squared of t. Because what does this equal? From our Pythagorean identity. Well, 1 minus the sine squared of t equals what? Well, remember, if we have to go back, if you forgot, remember if okay, I guess I could do it over here. Okay. And if I subtract the sine, I get the cosine squared of t equals what? 1 minus the sine squared of t. So doesn't this just equal the cosine squared of t? Sure does. That's the cosine squared of t. Remember I told you that we use that identity a lot. Okay, I think I did that in last night's homework. I talked about that. So 1 minus the sine squared of t equals the cosine squared of t. So I can write the cosine squared of t. So I've got the cosine of t on the top, 1 minus the sine of t on the bottom, and over here, I'm sorry, still on the top. And on the bottom, this is just going to be, so this is the top stays the same. I haven't done anything on the top. And I've used my Pythagorean identities to realize that this is going to be the cosine squared of t. Which is the same thing as the cosine times the cosine. One of these cancels, so now this is going to be the 1 minus the sine of t all over cosine of t. Because that's squared. Remember, x over x squared is just x. 1 over x. So these cancel. This is like the cosine times the cosine, so it cancels. And that's what I've got. And this is over on the left, you see. So this is 1 minus the sine of t over the cosine of t. Question mark, and we got a big check there. That's checked off because that's exactly the same. So by using those identities, that really helped. That saved a little bit of time and effort. All right. Okay, so I hope you understand why we did that. Again, I just put this here because I knew I had to get that up on the top because I've got that on the top on the left. So I just stuck it there, but what I do to the top, I got to do the bottom, and then that worked out. When I multiplied those out, I got this, and then boy, that's my Pythagorean identity all over the place. That's that. Those cancel, and I'm in business. So that worked out real nice. Okay, and let's take a look at 51. And 51, we want to show that cosine to the fourth of t minus sine to the fourth of t. 51, cosine to the fourth of t minus the sine to the fourth of t, okay, equals 1 minus 2 sine squared of t. All right, and again, this is a difference of perfect squares. I can see that right away, and this is going to be like the square root of that will be the cosine squared of t and the sine squared of t. So I know when I multiply these out, now this is nifty, so watch the way this works. This is pretty cool. This is going to be the sum and difference of these little numbers, right? So I'll put this over here. That's the sum and difference of those little numbers. That's the difference of perfect squares. So it's going to be cosine squared of t, sine squared of t, cosine squared of t minus sine squared of t. Well, what's this? Yeah, that's our good old Pythagorean identity. That's 1. So this is all I've got. I'm going to write it over here. But what's a cosine squared of t equal to? Isn't that 1 minus the sine? Back up here, actually, we can still see it. The cosine squared of t is the same thing as 1 minus the sine squared of t from our Pythagorean identity, right? And I want to get two of these, so instead of writing the cosine squared, I'll write 1 minus. And that's the cosine. Let me just bracket it here so you see this. And I have also a negative sine squared of t. So does that equal to 1 minus 2 of these? 1 minus, I got a negative sign, and negative, that's 2. So negative 2 sine squared of t. And there's my check. Yeah, because I've got 1 minus 2 of those, that's what that is. So by using our difference of perfect squares, this is algebra 1. A squared minus b squared equals a plus b times a minus b. They just have to be squares, or fourth powers. That goes to 1 by my Pythagorean identity, so now I just have this. So you can see that, that's going there. And I know that the cosine equals is from the same idea, that our Pythagorean identity. Here we go, we've got this, and we're done. That worked out real nice.